Am I audible? Am I audible? Good evening, everyone. Welcome to Goscore Learning, the fastest growing edtech company in Middle East. I'm your Dhanya ma'am with the last part of your electrochemistry chapter. Today, we are going to discuss about the batteries as well as about the corrosion. So, are you all ready? Can we start? Okay. So, first we can discuss about batteries. So, what is actually batteries? If a number of cells are connected in series. Okay, number of cells connected in series is what we call batteries. Okay, so batteries are if a number of cells connected in series, that arrangement is called a battery. Okay, and there are two types of batteries. The first one is the primary battery or primary cell, and the second one is the secondary battery or secondary cell. So now we can discuss about what is the difference between this primary battery and secondary battery. We can discuss it in detail. Okay. So first we can discuss about the primary battery or primary cells. So what does mean by this primary battery? The primary battery means that in that type of batteries, only one time the redox reaction will occur. That means we can use that battery only once. Okay, once the redox reaction is over, that battery is of no use. Okay, see, the primary batteries are those in which the redox reaction occur only once. Okay, those reactions in which the redox reaction occur only once and the cell become dead after some time. That after that redox reaction, the cell become dead. Okay, and cannot be used again. That means the primary batteries, we cannot reuse it or we cannot use it again. Okay, that type of batteries or that type of cells are what we call primary batteries or primary cells. Okay, so the primary cells are those cells or those batteries in which the redox reaction occur only once and the cell become dead after some time and it cannot be used again. Now let's see what are the main common examples for primary batteries, that are dry cell and dry cell and mercury cell. So we want to discuss in detail about the dry cell and mercury cell. Before moving on to that, we can see what you mean by the secondary batteries. Once we discuss the primary and secondary battery, we can discuss in detail about the dry cell and mercury cell. Okay, so I hope you are clear with the primary battery. That means in that the redox reaction occur only once and after some certain times the cell become dead and we cannot use that battery again. That type of batteries or cells are what we call primary battery or primary cell. Now see what is secondary battery. The secondary batteries are those batteries which we can recharge, which we can charge and can be used again. So secondary batteries are those which can be recharged by passing electric current through them and hence can be used over and again. That type of batteries are what we call secondary batteries or secondary cells. Now see the examples is the common examples is for secondary batteries are lead storage battery and nickel cadmium storage cells or nickel cadmium storage battery. Okay, these are the two examples. Now you got the difference between the primary battery and secondary battery, right? In primary battery, we can use that cell redox reaction occur. The cell will be active for some time and after that, after some period, after some time, that what happens, the cell became dead and we cannot use it again, right? And the examples are dry cell and mercury cell. And then the secondary battery or secondary cells, those cells as batteries which we can recharge by passing electric current through them and can be used again. And examples is for secondary batteries are lead storage battery and nickel cadmium storage cell. Now we can discuss in detail about the dry cell, mercury cell, lead storage battery and nickel cadmium cell one by one. Okay. So the concept about the primary and secondary battery, it is clear, right? Now let's see the example for the primary batteries. Okay, as we discussed, the one commonly used examples is a dry cell and mercury cell. First, we can discuss about the dry cell. Okay, see, the dry cell batteries we are mainly used in transistors and in clock. Okay, we're mainly using this dry cell batteries in transistors as well as in clocks. See, this is what the representation for a dry cell battery. Now see, here we can see a cylindrical zinc container, right? This zinc container will act as the anode. Okay, in this picture you can see the cylindrical anode, right? The cylindrical anode, this is the cylindrical zinc. Okay, zinc which will act as the anode. Okay, so in a dry cell, the cylindrical zinc will act as the cylindrical zinc container will act as the anode. Here see, in the mid of the cylinder, you can see a rod, right? This rod is made up of graphite, carbon. Okay, and this carbon rod, this black one, the cylindrical shape, carbon rod, this will act as the what? Cathode. This is the carbon or graphite rod which will act as the what? It will act as cathode, right? Now see, in between this cathode and anode, there is the electrolyte filled in that, right? What is that electrolyte? Zinc. In zinc, there is a paste of ammonium chloride and zinc chloride. On this, near to the zinc anode, there will be ammonium chloride and zinc chloride, plus on this carbon there will be manganese dioxide, MnO2. This will act as what? This all will act as electrolyte. Now see, in this cell we find out the anode, cathode and electrolyte. Okay, see here. This dry cell consists of a cylindrical zinc container, that is the zinc container will act as the anode, and a graphite rod is placed at the center which will act as the cathode, right? And in the zinc there will be paste of ammonium chloride plus ZnCl2, and the graphite rod is powdered with MnO2 and carbon. So we can say this ammonium chloride, ZnCl2, MnO2 will act as the electrolyte in dry cell, right? And the graphite rod is fitted with a metal cap. You can see here, this graphite rod is fitted with a metal cap, and the cylinder is sealed at the top with pitch, and this zinc container is covered with a cardboard. Okay, this is what the structure or what are there in the dry cell. Okay, now let's see. I hope it's clear. The zinc rod will act as the anode, that means where the oxidation reaction occur, and this carbon or graphite rod will act as the cathode, and the mixture of ammonium NH4Cl, ZnCl, MnO2 will act as the electrolyte. Okay, now let's see what are the reactions occurring in the dry cell. Okay, so for that, at anode what actually happen? The zinc will be converting into Zn2 plus 2 electron, right? So we already know that at anode what reaction will occur? The oxidation. That means here the oxidation is occurring. The zinc is converting into Zn2 plus 2 electrons, right? Now see what's going to happen in the cathode. Here what actually happen is MnO2 plus NH4 plus 4 electrons, right? Sorry, NH4 plus 2 electrons. We will be getting Mn2O3 plus NH3 plus H2. Okay, so 2 MnO2, 4, 3 plus 1, 4. Hydrogen, it's 3 there. So 2 NH3, 8, 3 plus 2, 6 plus 2, 8, right? So, this is what the reaction that occurring at the cathode, right? Okay, so see here, we can see that here ammonia gas is formed at the cathode, right? But in the cell, in the battery, this ammonia gas is not evolving out or not coming out. Why? Because this ammonia gas formed will be reacting with the zinc and the chloride ion. Okay, this ammonia will be reacting with zinc and the chloride ion, Zn2 plus ion and Cl minus ion, to form complex. That is what written here. It will form a complex, and this complex is called diamine dichlorido zinc. What is the name? See, 2 amino group is there, 2 chloride group is there, right? So, the name of that complex is diamine, that means 2 amine, diamine dichlorido zinc. Okay, so here the ammonia gas evolved at the cathode. The ammonia formed at the cathode is not liberated as gas. It will be reacting with the zinc and chloride ion to form a complex structure. Complex is diamine dichlorido zinc. Okay, so the complex formed is diamine dichlorido zinc. Okay, so here usually in the dry cell, these cells have the voltage in the range of 1.25 to 1.5 volt. Okay, and we know that they do not have a long life because here we are using the ammonium chloride. This ammonium chloride is acidic in nature, so definitely it will cause the corrosion, right? This dry cell, they do not have a long life because the acidic NH4Cl corrode the zinc container even when the cell is not in use. So, due to that acidic behavior of NH4Cl, these cells, the dry cells, do not have a long life. Okay. So, I hope the dry cell is clear. In the dry cell, we are taking the cylindrical zinc as the anode, and there is a graphite rod or carbon rod at the center of the zinc cylinder which act as the cathode, and there is a metal cap on this cathode carbon, right? And the mixture of NH4Cl, ZnCl2 and MnO2 will act as the electrolyte. Okay. This is about the construction, and we can talk about what the reaction, electrochemical reaction that occurring at the anode and cathode. At anode, what actually happened? The zinc act as the anode, right? The zinc will be losing 2 electron and form Zn2 plus ions, right? And at the cathode, the MnO2 plus 2NH4 plus will be reacting to form Mn2O3 plus 2NH3. This ammonia is not liberated as the gas because it will react with the zinc and chloride ion to form diamine dichlorido zinc. Okay, and these cells usually have the potential 1.25 volt to 1.5 volt. Okay, and due to the acidic nature of NH4Cl, these cells do not have a long life because this NH4Cl will cause the corrosion. Okay, that's about the dry cell. Now let's see about the mercuric cell. Okay, this mercuric cell is also known as button cell. Okay, and we are mainly using this mercuric cell in the hearing aids. Okay, in the hearing aids as well as in the watch. Okay, so we are using this mercury cell in the hearing aids and in watches. Okay. Now see what is the mercury cell. Okay. Here we have given, I have given the description. See, I will draw a figure. Okay. See, here it consists of a zinc container. Just hope this is your zinc container. Okay. And this zinc container will act as the anode. So here, the zinc container is acting as the anode. The zinc container acts as the anode. Okay, now see, there is a carbon rod which acts as the cathode. So I'm drawing a carbon rod here. There is a carbon rod which acts as the cathode. Right. This will be acting as the cathode. See, here the mixture or paste of mercuric oxide plus KOH that will act as the electrolyte. So here we have the electrolyte, the mixture of mercuric oxide or HGO, mercuric oxide plus KOH, right? The mixture of HGO plus KOH will act as the electrolyte. And see, here there is a porous lining. See, in between the zinc container and the electrolyte, there is a porous lining which will separate the electrolyte from the zinc container. Okay, see, this is what the setup of a mercury cell. In the mercury cell, the zinc container will act as the anode. Okay, the zinc container will act as the anode and the carbon rod placed at the mid will act as the cathode. Okay, and there will be the electrolyte which is the mixture of mercuric oxide plus KOH. And the zinc container and the electrolyte is separated with a porous lining or a porous paper. So, a lining of porous paper which keep the electrolyte separated from zinc anode. This is what the setup of a mercury cell. Okay, now let's see what is the reaction that taking place. This is what the representation of the mercury cell, or you can draw it like this. Okay, now let's see what is the reaction that occurring at the anode and cathode. Okay, see, at anode Zn plus 2OH minus is giving ZnO plus H2O plus 2 electron. Okay, at cathode HgO plus H2O plus 2 electron, it is giving Hg plus 2OH minus. Now let's see what is the overall reaction. I am writing the reaction that occurring at the anode. Okay, at anode what actually happened? The zinc plus 2OH minus is giving ZnO plus H2O plus 2 electron, right? And at cathode, what's the reaction? HgO plus H2O plus 2 electron gives what? Hg plus 2 OH minus. Now we want to write the overall reaction, right? So for that, see, here we can cut the 2 electron, 2 electron, 2 OH minus and 2 OH minus, right? And here H2O, H2O, right? What will be the overall reaction you are getting? Your overall reaction will be Zn plus HgO gives what? ZnO plus Hg, right? See, in the overall reaction, there is no free ions involved, right? In the overall reaction, does not involve any ions whose concentration. If there is any ions present, then only its concentration will be varying, right? Since in the overall reaction, there is no involvement of any ions, the concentration, the cell potential of this mercuric cell is constant throughout its lifetime and its value is 1.35 volt. Okay, see, as the overall cell reaction does not involve any ions whose concentration may change, the cells give a constant potential of 1.35 volt throughout its lifetime. Okay, that is the special about the mercuric cell. In the mercuric cell, in the overall reaction, there is no involvement of free ions. So, this mercuric cell will give a constant cell potential of 1.35 volt throughout its lifetime. Okay, so I hope the mercuric cell is clear for you. The mercuric cell is also known as the button cell and it is mainly used in the hearing aids and in the watches. In the mercuric cell, it consists of a zinc container as the anode and a carbon rod as the cathode, and the electrolyte that we have used for this mercuric cell is the mixture of mercuric oxide and KOH, and there is a porous lining which separates this electrolyte from the zinc anode. Okay, that's about the mercuric cell, and in the overall reactions we have seen that there is no ions, so it gives a constant potential of 1.35 volt throughout its lifetime. That's about the primary cells. We have discussed in detail about the primary cells. In that, the common examples, dry cell as well as the mercuric cell. So I hope this is clear for you. Now can we move on to the secondary batteries or secondary cells? So about the secondary cells. The secondary batteries, as already we mentioned, can be charged and can be reused again, right? So the common example for secondary battery is lead storage battery. Okay, in lead storage battery, this lead storage battery is mainly used in the automobiles and in the inverters. Okay, so we are mainly using this lead storage battery in the inverters and in the automobiles. So now let's see what a lead storage battery consists of. Okay, the lead storage battery, it contains lead anode. Okay, see here the representation. It has a negative plate lead grid with the spongy leads and positive plates that is the lead grids filled with the PbO2. Okay, so here the lead acts as the anode, and what is the cathode? The cathode is the grid of lead packed with the lead dioxide. So see here the positive plates with the lead grids filled with the lead dioxide which act as the cathode, and the lead grids filled with the spongy leads which will act as the anode. That's the cathode and anode of the lead storage battery, and these electrodes are arranged alternately. Okay, and what is the electrolyte here we are using? See, these electrodes, cathode, lead anode and lead grid packed with lead dioxide act as the cathode, and this cathode and anode are arranged alternately. Okay, and these are cathode and anode is usually separated by a wood fiber or fiberglass, and these two cathode electrodes, cathode and anode, is suspended in the dilute H2SO4, that is dilute sulfuric acid solution. This act as the what? This act as the electrolyte, right? This is the setup of the lead storage battery. Okay, in the lead storage battery, the lead act as the anode and a grid of lead packed with the lead dioxide act as the cathode, and these two cells are arranged alternately one after another. It is arranged alternately, and there will be a wooden or fiber sheets to separate the electrodes, and this whole setup is immersed in the dilute H2SO4 solution which will act as the electrolyte. Okay, that's the what about the lead storage battery. Now let's see what are the reactions taking place at cathode and anode in the lead storage battery. See, lead storage batteries are the examples is for secondary batteries, right? So we can recharge, we can charge it using the electric current and can be reused again. So see what is the reaction taking place during the charging time and during the discharge time. Okay, discharge, first we can see the what the reaction occur during discharge. During discharge means the battery when we are using the battery. That means the battery is in use, right? During discharge means the battery is in use. When you are using the battery, what the reaction is taking place. See, at anode, lead plus SO4 2 minus, we are getting PbSO4 plus 2 electron. That's what the anode, the oxidation reaction is taking place, right? And at cathode, the PbO2 plus SO4 2 minus plus 4H plus 2 electron is giving PbSO4 plus 2H2O. Now let's see what is the overall reaction. At anode, the oxidation of lead plus sulfate ion to form lead sulfate, we're releasing 2 electrons, and at cathode PbO2 plus SO4 2 minus plus 4H plus is accepting 2 electron to form PbSO4 plus 2H2O. Okay, that means the reduction reaction is occurring at the cathode. Now let's see the overall reaction. I am writing the anode reaction first. Pb plus SO4 2 minus is giving Pb SO4 plus 2 electron, and at cathode what the reaction going on? PbO2 plus SO4 2 minus plus 4H plus 2 electron giving PbSO4 plus 2H2, right? Now let's write the overall reaction. See this 2 electron get cancelled. Now see here Pb plus PbO2 plus 2SO4 2 minus, right? SO4 2 minus plus SO4 2 minus, we are getting 2SO4 2 minus plus 4H plus is giving what? PbSO4 plus PbSO4. That means 2 PbSO4 2 PbSO4 plus 2H2O, right? This is what the overall reaction that occurring in the lead storage battery when we are using the battery. When the discharge, during discharge time, that means we are using the battery. This is what the reaction that takes place at the anode and cathode. Now see, very interesting factor. See what is happening when we are charging the battery. That means we are giving the electric current. We are allowing the electric current through the battery, right? So electrical energy is supplied to battery in the form of from an external source. That's what occurring when during the charging. That means at that time the battery is not in use, right? The battery is not in use. Okay. See, when the battery is not in use, we are charging the battery, right? So we are providing the external electrical energy from an external source to charge the battery, right? Here, see, what actually happens is the electrode reactions are getting reversed. See, when you are charging the battery at anode, what actually happens? The lead plus SO4 2 minus is giving PbSO4 plus 2 electron, right? When you are discharging or when you are recharging the battery, what actually happens is this PbSO4 plus 2 electron will give you back this Pb plus SO4 2 minus. See what the reaction is occurring at the cathode? PbSO4 plus 2 electron is giving Pb plus SO4 2 minus. It is just the inverse of what happened in the anode during discharge, right? What the thing is happening at the cathode or anode during the discharge time, it's inverse. It's just opposite or inverse is what happening during the recharging. See, this is what happening during the charging. This PbSO4 is gaining 2 electron to form Pb plus SO4 2 minus. And see what the reaction is happening at the cathode during the discharge. See, PbO2 plus SO4 2 minus plus 4H plus 2 electron giving PbSO4 plus 2H2O, right? So, when you are charging it, the reverse will occur. PbSO4 plus 2H2O will be giving back PbO2 plus SO4 2 minus plus 4H plus 2 electron. See, that's what happening at anode when you are discharging, when you are charging the battery, right? So what we can say simply, the electrodes which act as the anode during charging act as the cathode during charging. The electrode which act as anode during discharge act as the cathode during charging, vice versa. See, here we can write the overall reaction. Okay, and there is the change in the cathode and anode also, right? That's what we mentioned here. The electrode which act as here at the cathode, the lead sulfate is occurring. See here at the anode, the lead plus sulfate ion is forming PbSO4 plus 2 electron, right? That's what we mentioned here. The electrode which act as anode during discharge act as the cathode during charging and vice versa. That is what happening in the cell, lead storage cell, when you are charging it and when you are discharging it. So I hope it is clear when you write the overall reaction that occurring in the charging. During charging, it will be just simply opposite of what we get during the discharge, right? Write it. We will be getting 2 PbSO4 plus 2 H2O. These 2 electrons will be getting cancelled. We will be getting Pb plus PbO2 plus 2SO4 2 minus plus 4H plus. It's simply what the inverse of what we get here. During the discharge, the simply opposite as inverse is what we are getting during the charging time. And the main important thing is here, see, at cathode, the PbSO4 is gaining the 2 electron. Here, see, at anode, the Pb plus SO4 is giving the PbSO4 plus 2 electron. That is the main change. The electrode which act as the cathode or anode during the discharge will act as the anode. Okay, so the electrode which is acting as the anode during discharge will act as the cathode during the charging, vice versa. Okay, that's about the lead storage battery. Now let's discuss the one more secondary cell battery, that is the nickel cadmium storage cell. Okay, that's the nickel cadmium storage cell, or is also known as NiCad cell. Okay, nickel cadmium, that is what the NiCad cell. Okay, so in the nickel cadmium cell, this is actually more popular. Okay, this is a rechargeable cell which will becoming more popular nowadays. But the problem is that it has a longer life than the lead storage battery. It is more expensive. It is more expensive than the lead storage battery. But when you compare the lifespan, this nickel cadmium battery is having more long life, or is more life than that of the lead storage battery. Okay. And here also, this nickel cadmium means it contains the cadmium electrode which act as the anode, and a metal grid containing nickel 4 oxide act as the cathode, and the electrolytic solution is KOH solution. And these are the reactions that were occurring at the anode and at the cathode. Okay, see here, cadmium plus 2OH minus is giving CdOH twice plus 2 electron and NiO2 plus, this is what the reaction happening at the and cathode. Okay, this is about the nickel cadmium storage cell. You should know what is acting as the anode. Here the cadmium electrode is acting as the anode and the metal grid containing nickel 4 oxide acting as the cathode and KOH solution is acting as electrolyte. Okay. So, I hope you are clear with the primary batteries and secondary batteries. In primary batteries, we have discussed in detail about the dry cells or dry and mercury batteries, and in the secondary batteries, we have discussed about the lead storage battery and nickel cadmium storage cells. So, I hope this primary and secondary battery is clear for you. And in the secondary battery, the main thing is that in the lead storage battery, when you are charging and discharging, the cathode and anode is getting inversed and the reaction is just opposite is occurring, right? So that is what about the lead storage battery and nickel cadmium battery. Okay, now we are moving on to the fuel cells. Okay, see what is fuel cells. Okay, so what is fuel cells? Fuel cells are those devices which will convert the energy produced during the combustion of like a hydrogen or methane or methanol to convert this energy into the electrical energy. See, the fuel cells are devices which will convert the energy produced during the combustion of fuels like hydrogen, methane, etc. directly into electrical energy. So, in the fuel cell, what is happening? The energy produced by the combustion of fuels like methane or hydrogen, it will be converting directly into electrical energy. Okay, so the commonly known example for fuel cell is the hydrogen oxide oxygen fuel cell, H2O2 fuel cell. Or it is the hydrogen oxygen fuel cell. Okay, and where we are actually using this fuel cells, are having a primary usage in the, they are used as the primary source of electrical energy in the Apollo moon flights. In the Apollo moon flights, we are using this fuel cells as the primary source of electrical energy. Now let's see what is there in the fuel cells and how the electrical energy is produced. Okay. So in the fuel cells, see here we can see the diagrammatic representation. In the fuel cells, there is a porous carbon. This is the porous carbon coated with the catalyst. Okay, what I am marking with this red thing, this one, this portion. Okay, this is the porous carbon which will act as the cathode and anode. See, it consists of the porous carbon electrode containing the suitable catalyst in that. That will be, we will be using the finely divided platinum, palladium or silver as the catalyst there. Okay. So, these are the electrodes. Okay, this is the porous carbon electrodes. And here what is the, see here what the electrolyte we are taking. This is the aqueous electrolyte, right? The electrolyte we are taking is the mixture, either concentrated KOH or NaOH solution. So, here what we are taking is NaOH or KOH solution. And you can see from the figure that through the opening, we are passing the hydrogen and oxygen gas under high pressure into the porous carbon membrane, and through this porous carbon, it will be entering into the electrolyte. Okay. So, here the hydrogen and oxygen gases are bubbled through the porous electrode into the KOH or NaOH solution. See what the reaction that occurring. See here at the anode what happened, the 2H2 plus 4OH minus is giving 4H2O plus 4 electron, and at the cathode O2 plus 2H2O plus 4 electron is giving 4OH minus. So when you write the overall reaction, what will be the overall reaction? Here, this 4 electrons and this 4 electron get cancelled. This 2H2O cancelled with the 4H2O and the remaining is 2H2O, right? This 4OH minus on the left side get cancelled with its 4OH minus on the right side. And what is the net equation or the overall reaction? 2H2 plus O2 gives what? 2H2O. This is the overall electrochemical reaction that occurring in the fuel cell. And in the fuel cell, what happens? The porous carbon, which is coated with a finely coated with a catalyte like a platinum, palladium or silver, will act as the electrodes, and aqueous electrolyte is the electrolyte. The aqueous electrolyte that we use will be either NaOH or KOH, and hydrogen and oxygen gas is bubbled into this electrolyte solution through this porous carbon electrodes. Okay, this is what the setup of a fuel cells. Now see the what are the advantages of the fuel cells. Okay, so as I told you, compared to the other cells, what are the main advantages of fuel cells? See, because of the continuous supply, these fuel cells will never become dead. That is the main advantage. Because of the continuous supply, these cells will never become dead. And theoretically, when you calculated, this fuel cells can produce the efficiency of around 100%. But in practically, we are getting about 60 to 70% efficiency from the fuel cells, which is higher than that of from a thermal plant. So, in the fuel cell, we are getting more efficiency. We are getting around 60 to 70% efficiency when we are using the fuel cells. And the main advantage is that unlike other fuels, thermal plants which use the fuels like petroleum, diesel, etc. In fuel cells, there will be very less amount of pollution. They will not cause any pollution. Okay, that is the main advantage of the fuel cells, that they do not cause pollution problems unlike a thermal plant. We know that from the thermal plant we are getting a lot of pollutions. Unlike them, this fuel cells will not cause any pollution at all. These are the main advantages of the fuel cells. Okay, now let's see what are the difficulties. Okay, even though if it have this much of advantages, what are the difficulties that we are facing with the fuel cells? So, the main difficulty is in a fuel cells we have to provide the contact between the three phases as very needed in the fuel cells, that is with the gaseous fuel, the liquid electrolyte and the solid catalyst. Their contact will be, we have to maintain, and the corrosiveness of the electrolyte used. We are using the NaOH or KOH solution which is corrosive in nature, and the corrosive nature of the electrolyte is the major problem that we are facing, difficulty that we are facing with the fuel cells. And of course, as I mentioned you, in the fuel cells we are using the porous carbon coated with the platinum, palladium or silver catalyst, right? These all are very expensive, right? That is the third point, the high cost of the catalyst needed for the electrode reaction, that is the platinum, palladium or silver. And in the fuel cells we have to handle the gaseous fuel cells under high pressure and at a low temperature. That is the fourth difficulty that facing with the fuel cells. Okay, so these are the main four difficulties in the construction of the fuel cells. That means in the fuel cells we have to provide the contact between the three phases, that is the gaseous fuel, liquid electrolyte and the solid catalyst. The second one is the corrosive nature of the electrolyte that we are using, that is the NaOH or KOH. And the next one is the catalyst. We are providing the catalyst, the platinum, palladium or silver, which all are expensive in nature, and we are handling with the gaseous fuels at a The handling of gaseous fuels at a low temperature and a high pressure will be fourth difficulty. So I hope you are clear with the fuel cells. What are the advantages of fuel cells and what are the difficulties that we are facing with the fuel cells. Okay. So until now we have discussed about the batteries, the primary battery, secondary batteries along with their examples and explanation of each type of batteries. 4 batteries we have explained and the fuel cells also. Okay. Now we are going to discuss the last portion, that is the corrosion. Okay. So corrosion we are learning from our lower grades itself, right? So you all are familiar with the corrosion. So what is actually the corrosion? The corrosion is the slowly eating away of the metal. We know that the metals is reacting with the atmospheric oxygen, carbon dioxide and water vapors, and it will be losing its lustrous nature, right? So the process of slowly eating away of the metal due to the attack of atmospheric gases on the surface of metal, resulting into the formation of compound such as either oxides, sulfides, carbonates or sulfates, which are what we call corrosion. So, the corrosion is the slowly eating away of the metal due to the attack of the atmospheric oxygen, and the surface of the metal will be resulting in the formation of carbonate, sulfate, sulfide or oxides is what we call the corrosion. Okay. So, now see what is actually happening. We know that common examples is for the corrosion. We know, we are familiar with it, that is the rusting of iron, the green color coating formed on the copper, and also tarnishing of silver. They all are, you have learned about them, lot of examples of the corrosion in your 10th, 11th, lower grades itself, right? So now see what is actually the electrochemical principle, that what is happening, what is the, how the rust is forming. Okay, see, actually what actually happens is, we know that in our atmosphere there is oxygen and carbon dioxide gas. Okay, and on the surface of metal there will be water vapors. Okay, this water vapor will react with the carbon dioxide and oxygen to form the carbonic acid. Okay, this water reacting with the carbon dioxide and oxygen to form H2, sorry, H2CO3. Okay, this is what the carbonic acid is forming, right? This carbonic acid will dissociate to form what? I'll write it in the next slide. Okay. Initially, what happens? The water vapor reacting with the carbon dioxide and oxygen to form what? H2CO3. This H2CO3 will be dissociating to form 2H plus plus CO3, 2 minus ions, right? Now, this is what the first step. Okay, the water vapors on the surface of metal dissolves carbon dioxide and oxygen from the air. This carbonic acid formed will act as the electrolytic solution. This carbonic acid will be dissociating to form the H plus and CO3, 2 minus ions. Now see, when the iron comes in contact with the electrolyte solution, that means this carbonic acid solution, this iron will undergo oxidation, and this where this in the metal rod, where this reaction occur, it will act as the what? Oxidation is occurring at the anode. So in the metal rod, where this reaction, that is iron reacting with the, sorry, the iron Fe will be changing into Fe2 plus plus 2 electron, and in the metal rod where this reaction is occurring will act as the what? anode. Okay, this will act as the anode. Okay, now see the third one. The electron lost. See here we have lost one electron, right? This electron lost will reduces the dissolved oxygen in the presence of H plus ion and it will act as the cathode, right? See, this oxygen plus H plus ions plus 4 electrons, it will be changing into water. Okay, so here 4H plus H. Okay, so in the metal rod where this reaction occurring, it will act as the cathode. Okay, now we can find the overall reaction. What will be the overall reaction here? Check for the overall reaction. We have to multiply this equation with the 2, right? So your equation will be 2Fe 2Fe giving 2Fe2 plus 2 electron. And what the reaction occurring, electrochemical reaction at the cathode? O2 plus 4H plus 4 electron giving 2H2O, right? So when you write the overall reaction, what will happen? This 2 electrons will be, so we are multiplying this with 2, right? So here it will be 4 electrons, right? We are multiplying the whole equation with 2, right? Sorry. So here it will be 4 electrons, right? So this 2 electrons will be getting cancelled. Okay. So what will be your final equation will be coming as 2Fe plus O2 plus 4H plus is giving 2Fe2 plus 2H2O, right? This is what the overall reaction that you are getting. Okay, now see, this is the third step, right? See, the electron lost reduces the dissolved oxygen in the presence of H plus ions which act as the cathode. We got the anode, cathode and we find out the overall reaction, right? Now, what happens is the ferrous ion formed. So here the ferrous ion is formed, right? Fe2 plus ions formed, right? The ferrous ion formed react with oxygen and water and ferric oxide and H2O is for H plus ions is forming there. See, ferric ion react with oxygen and water. So here we can write the third step. The Fe2 plus ion react with the oxygen and water leading to the formation of Fe2O3. Okay, and H plus ion is forming them. Okay, so when you balance this equation, O3, 3H2O. So when you are balancing the equation, you will be getting the 4H2, 2O3, 2F3, 2 are 6, 6, 4 plus 2, 6, 4 plus 2, 8, 8 H plus. Okay, this is the balanced equation for the fourth step, right? We are getting 2 Fe2 plus, sorry, not 2, 2 2s are 4, right? 4. 4 Fe2 plus, 4 Fe2 plus, I will rewrite it again. Sorry. 4 Fe2 plus O2 plus 4H2O, you are getting 2 Fe2O3 plus 8 H plus ions, right? So that is the fourth step. See, the last what happens? This ferric oxide then undergo hydration. So what we got here? Fe2O3, right? This Fe2O3 will undergo hydration. The Fe2O3 will be reacting with X molecules of water to form what? Fe2O3 dot XH2O. This is what called a hydrated ferric oxide. This is what we called hydrated ferric oxide. That is what the rust. And we know that this rust is not a sticky substance. It is a flaky substance. It will be removed from the surface of the metal and the next layer will be exposed to corrosion, right? So this is what the formation of rust. So in the formation of rust, what actually initially happened? The water molecule on the surface of the metal reacting with the carbon dioxide and oxygen in the air to form the carbonic acid. This will act as what? Electrolyte, right? This will act as the electrolyte, and this carbonic acid dissociate to form the H plus and CO3 2 minus. And in this here what actually happens, the iron rod will be converting into ferric Fe2 plus will by losing 2 electron, and this will the surface of the metal where this reaction occurring will act as the anode, and due to this released electrons the oxygen will be reacting with 4H plus ions to form 2H2O, and this will act as the cathode. Okay. Now, when you write the overall reaction, the Fe2 plus ions formed will be reacting with the atmospheric oxygen and water molecule to form ferric oxide. This ferric oxide will undergo hydration to form the rust. That is the hydrated ferric oxide is what we call rust. Okay. Now see what are the factors which promotes the corrosion. As we know that as the reactivity of the metal increases, there are more chances for the corrosion, right? So the reactivity of the metal is the one factor which affect the corrosion. The second one is if there is more impurities in the metal, there are more chances, they are more prone for corrosions. Okay. If the metal is pure form, then there is less chance for corrosion. If there are more impurities, the chances for corrosion is more. Okay. And of course, if the air and moisture is present, definitely there will be more chances for corrosion. And if there is strains in the metal like bends or any scratches or something on the metal surfaces, it will lead to the chances for corrosion more. And of course, the presence of electrolyte, we may have heard that the metals on the seashore will be having more corrosion because the presence of the NaOH plus water, NaCl plus water, NaOH, the presence of the electrolyte will enhance the chances for corrosion. So these are the factors which promotes the corrosion. Okay. So these things is you are already familiar with your lower classes itself. Okay. So I'm not stressing it more. And the prevention of corrosion, that also you know, the first method is the barrier protection that we are giving by the painting or by putting the oils or grease something. And we know that chromium plating is done on the iron objects to prevent it from the corrosion. The second method is the sacrificial protection method, that is what the galvanization. So in the galvanization what we are doing, we are giving a coating of more reactive metal on the iron objects, right? So usually we will be providing the coating of zinc on the iron object. So what actually happened, as the zinc is more reactive, it will react with the atmospheric oxygen and will form a protective layer on the iron rod, right? And thereby prevent the iron from getting corroded, right? So this is what the happening in the galvanization. So in the galvanization, we are giving a protective coating of zinc over the iron objects and thereby preventing it from the corrosion. And the next method is using the anti-rust solution or by electrical protection or cathodic protection method. These are the methods that we can use to prevent the corrosion. Okay, that's about the corrosion. Okay, and the last portion in this chapter is the hydrogen economy. Hydrogen as the renewable and non-polluting source of energy. We know that the fossil fuels that we are using, the petrol, diesel, etc., they all are non-renewable energy resources, right? So, and also they are causing pollutions, right? But hydrogen as an energy source is a renewable energy source and it is non-polluting. Okay, the fossil fuels, coal, oil, gas are non-renewable and cause pollution. Hydrogen is a renewable source and it is a non-polluting source of energy. And we can produce the hydrogen by the electrolysis of water. And this we are using this hydrogen for making the fuel cells. That's what we discussed today, right? So the future version of energy is the hydrogen economy. Since it is a renewable source and it is a non-polluting one, and we can easily prepare it from the hydrolysis of water. So we can say it is the hydrogen economy for the future vision of energy. With this, I am winding up the electrochemistry chapter. So in the 4 parts of electrochemistry, we have discussed the whole chapter, and I have included the numericals based on this particular chapter also. So I hope this chapter is clear for you. So stay tuned with Goscore, and your Nandini ma'am will be coming on live on the coming Tuesday with your physics topic. Until then, stay tuned with Goscore Learning. Thank you all.